All right, this will be our last official lesson in our 7th grade curriculum for this school year. And we are going to be talking about compound events. As usual, I have my list of things to do, and recently I've added watch the videos, watch it all, watch what you need. Remember, you can pause and replay. A reminder that a lot of the videos about probability, a lot of the problems seem pretty easy, but there might be some nuances in there that you could learn a little bit more about if you watch the videos. So, our problem today is we have a person named Nina, and Nina is buying a new pet fish. At the pet store, the fish tank has an equal number of two kinds of fish, tetras and guppies. Each kind of fish comes in 4 different colors: yellow, orange, blue, and silver. There are an equal number of each color fish in the tank. If Nina scoops out a fish at random, what is the probability that she will scoop out a silver tetra? All right, so if we go back and we think about the things that were in our problem up above, there are some things that we need to be remembering. One is that there are 2 kinds of fish and that they come in 4 different colors. So when I look at that, and I like to kind of go down into where it talks about the explanation, because that might help to think about this problem a little deeper and help us to be more accurate and precise from the very beginning of our work today. We have 2 types of fish, and we can multiply that by 4 colors, which gives me 8 fish. And if we scoop out 1 fish, gives me a 1 out of 8 probability or chance. And so up here, I'm going to write 1/8, and I've got my thinking down here. Sometimes when we're asked to explain, it's sometimes often a lot easier to explain and think about what we're going to write for that as our evidence if we do the thinking and the processing as we are trying to find the answer, and then we write it down right away. All right, so then Nina set up the table below to organize the different possible outcomes because she wants to be really, really clear on what the possibilities are. She represented the kind of fish on one side of her table and the color possibilities on the other. So we have the color up top, we have the kind of fish on the left-hand side. What do the fractions inside her table represent? And so we have yellow, YT means yellow tetra, OT means orange tetra, yellow guppy, and so on. The fractions represent the probability that she will scoop out different kinds of fish. Pretty straightforward there. And next, we are going to look down underneath the table, and we have a little bit more information. As Nina looked at her work, she noticed that her table looked a lot like a rectangle with the area divided into parts. Could that help me with the probability, she wondered? She used the length and the width of the silver tetra section to set up this equation. 1/4 times 1/2 equals 1/8. How does this equation relate to the length, width, and area of this section of the rectangle? Does this match the probability you found in part 1 or part A? Well, 1/4 and 1/2 are the length and width of the sections. And 1/8 is the area of each section. What is the area of the complete large rectangle? Well, it's the area of the whole thing, so the area of the whole would be 1. Take up all our little fractions. 1/8 plus 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 1/8. That would be 8/8, which is equal to 1. Right, then we are going to move on to our next problem. And we have Nina again, and she is trying to decide if thinking about finding area would help her find other probabilities. She put 3 cubes in a bag, 2 blue cubes, and 1 yellow cube. She pulled 1 cube out, put it back in the bag, and then drew another. Use a systematic list or probability tree to organize the possible color combinations she could have. She could draw. And what would they be? So as we take a look at this, um, I am going to go to the loose leaf paper that I have underneath here, and I'm going to make a probability tree. So we are going to, I'm going to start here, and we have a blue cube, we have a blue cube, and we have a yellow cube. And then off of this, I could get a blue, or a yellow. Off this one, blue, blue, yellow. And here I would get a blue, or a yellow. And as I take a look at this, how many combinations are there? I look at the end of my tree where all the branches are nice and kind of squished up here. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many are there? There are 9. Go back to this. There are 9. What is the probability of blue and blue? Well, the probability of blue and blue, we've got 1, 2, 3, 4, and that's it because we are branching off from yellow down here. So we have 4/9. Going back here, we would put 4/9. Now, this time, Nina made the tablet right. Based on the table, what is the probability of drawing 2 blue blocks? We have 1, 2, 3, 4 out of 9 possible. Is it the same probability? Absolute yes. And then Edwin says, after looking at her work, I think I can simplify this diagram. And so what Edwin does is he combines them in such a way, and he labels the edges with the probabilities. And the question that we have for Edwin is, what is the area of the section representing blue and blue? Well, it's 2/3 or 4/9. Does this match the probability that Nina found? Yes, it does. All right, you are now on your own to finish the rest of this assignment. Please remember that there will be a review of this lesson for you to watch posted on Wednesday. I know it's a no new work day, but I'll have a video of this lesson review so you can see how accurate and precise you are doing and how well you're doing with our probability work. Summative on Thursday, last one of the year.